Okay, guys, today we're going to look at the picturing squares problem. And on the board here, I've written the question. So 1 plus 3 plus 5 plus 7 is 16, and it's illustrated by this. Let me explain what this is first of all. This is the 1, and if you have one circle, it kind of forms a 1 by 1 square. Then you add 3 circles, whatever, it doesn't matter what they're represented by, you add 3. And you have 4, right? You add these 3 blue ones, and you have formed a 2 by 2 square. It's 2 long and 2 high. Then you add the next odd number, which is 5 black ones, and you have formed a 3 by 3 square. It's 3 long and 3 high. Then you add the next one, which is 7. 1, 2, 3, 4, 5, 6, 7, and you formed a 4 by 4, which is 16 total circles. Similarly, if you were to do the next term, you would add 9, which is the next consecutive odd number. I would put 1, 2, 3, 4 here, an extra one in the corner, and 1, 2, 3, 4 here, and I would form a 5 by 5 square, which is also 25 circles. Okay, so the first part of the question says, okay, so if we can find a pattern here, can we work out what is the sum of the first 30 consecutive odd numbers? Now, it's not necessary to write it, but if we were to write it, the question um, would look like this. 57, 15. What's the answer to that question? Okay, so without doing this, without adding circles, let's try and look for patterns and solve the first part of the question. You can pause the video and I'll tell you the answer in a minute. Okay, so we have to recognize that the number of terms directly correlates to the number of circles in the row, which is exactly the same as the number of circles in the column, right? So if we have 30 terms, we would have 30 circles in a row and 30 circles in a column, making a very big square. But we can work out how many circles are in that very big square if we know that there's 30 in a row and 30 in a column. The answer to the first part is simply 30 times 30, which is 900. Similarly, the second question is a tiny little bit more difficult, but the same reasoning. How about if I have the first 60 consecutive odd numbers added together, what would be the sum? Based on the exact same logic that we used here, the sum of this would be 60 times 60, which is 3,600. Part C then is asking us to find a pattern. I know they're not numbered A, B, C in the worksheet, but for simplicity, find a pattern. So how can we work any question like this? What's the first 50 odd numbers added together, or the first 1,000 odd numbers added together? How can we work that out quickly? Can we derive a formula or a pattern? And the answer is, of course we can. We have 3 examples. Using logical reasoning, it must always work, right? Because we just add on another row and column, and another row and column, and another row and column for any number. So the answer to C is it's just the number of terms times the number of terms, which in another easy way can be written as the number of terms squared. So then B, this will be the last question I write on this board before I clear the board, and we'll look at the more difficult stuff. D is asking, is this number, can this number be formed with a square like this? So can this number be written as 1 plus 3 plus 5 plus up to something? And the answer is, I don't know because I haven't checked, but you can quite easily check by using your formula. So if this can be written as this, then there must be a number of terms, right? And this must be the number of terms times the number of terms. That's what we deduced in part C. So to work that out, we would just find out if this is a number, a real number, not a real number, a whole number, a natural number. So is this not a decimal? If this is not a decimal, then yes, it can be written as this, because we found that that's the pattern, right? We wrote it in part C. The next part of the question is more difficult, and it's asking you to solve this. We already have a formula, but we have to do a little work first. So we know that the formula is the number of terms times the number of terms, right? But we don't know how many terms are there. Oh, I should mention, before I go over the answers to each part, pause the video and try and do it by yourself. Okay, so how can we work out how many terms there are? Well, let's take an easier example from earlier. And we had this, right? There are clearly 4 terms there. If we have this, there are 5 terms, etc., etc. And obviously, these are half of the numbers between 1 and 10, right? Because there's even numbers in the middle. Right? They're half the numbers between 1 and 10. So the way that we can work out how many numbers are in the sequence is to add 1 and divide by 2. Because there are even numbers all the way in the middle. So the way that we can work out the number of terms is to add 1 and divide by 2. And you can check that if you want to with several examples, but add 1 and divide by 2 gives us the number of terms. Okay, so after we have the number of terms, we can very quickly work out what this is. So for this particular question, the number of terms is 153 plus 1 divided by 2, which is 77 terms. And we know from our formula that we worked on before that this sum, or the number of circles in the square, is equal to the number of terms times the number of terms, which is, in this case, 77 times 77, which equals 5929. If we want to visualize this, which we will because it'll be useful later on, this is the square 77 and 77. Okay, for this question, the next part is easier, actually. It just requires one little jump, which we can deduce by knowledge of 1 plus 3 plus 5 is the same as 5 plus 3 plus 1. So we can sort of flip this around so that it looks like what we know. It looks like sequences that we know how to solve. So this is the same as this, right? Yeah, like we've done before. And number of terms would be 83 plus 1 divided by 2, which is 42 terms. You can count them if you want to. There are 42 terms in the sequence. And the number of circles in the square, if you like, is number of terms times number of terms, like we said it was in part C. And this would be 42 times 42, which is 1,764. 1,764. That's the answer. Okay, the next question is legitimately quite difficult. Try by yourself first, and then we'll go through it together. The easy way to sort of do it is think about the square with circles in, and what is missing from the square related to what is missing from this equation that you know how to solve. So we already know how to solve this if it starts at 1, right? 1 plus 3 plus 5 all the way to 153. We solved it earlier. We understood that there were 77 terms, and we did 77 times 77. We solved for the whole square. If this square is 77 long and 77 tall, that is 1 plus 5, 1 plus 3 plus 5 plus 7, dot, 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 all the way up to 153 is this. Right? We know that. However, the first part is missing. Now, where is the first part? If we remember, how did we build up our squares in the first place? We had one by one square, and then added 3 to get a 2 by 2, added 5 to get a 3 by 3 square, added 7 to get a 4 by 4 square, and it expanded this way, right? So, approximately, this part is missing, right? This part is missing from our sum. So if we know the whole square, we can take away this part. In the same way that if we know the whole equation from 1 plus 3 plus 5 all the way to this, we can take away this part. Okay. So can I write this part? What is this? Well, this is 1 plus 3 plus 5 up to 49. Right? That's what we have to take away from the start to get our answer. Okay. So then we need to do a little bit of work and solve this. So the number of terms between 1 and 49 is 49 plus 1 divided by 2, which is 25. 25 terms. And the area here is 25 times 25. Number of terms times number of terms. Right? Which we did before. Which is 625. From our answer before, this whole big square, 77 times 77, which was 5,929. If we take away this, then we get this part, which represents our question. Okay, so then we just have a simple math to do. We do 77 times 77, which we learned earlier, minus 25 times 25. In other words, 1 plus 5 plus 7 plus 9 2 plus 153. Take away 1 plus 3 plus 5 plus 7 plus 9 up to 49. And we get 5929, sorry. 5929 minus 65, which equals 5304. Answer. Okay, for this question, It's tough and it requires some thinking skills. So we have to think about how does this look similar to what we know already, which is odd numbers added together. Right? We know how to solve this. We don't know how to solve this, but how does this look like this? Well, we'll notice that on the red line, each number is one smaller, right? Each number is one smaller. So for every term, I have an extra one, and an extra one, and an extra one all the way up. We can just answer from there, or we can try to visualize it. Okay, cool. So I start with one circle. I'm trying to make a square here, to understand. But I have an extra one. Okay, my extra one, I'm going to just throw it over here. So I have two. Okay, next term is three. And I've formed my 2 by 2 square, and I have an extra one. I have an extra one before. Okay, plus 5. But again, I have an extra one. And I can do this forever. Or I can do this until I get to 153, which I'm not going to do. But let's try and see the pattern here, yeah? So I can form a triangle, sorry, I can form a square that is 153 by 153, and I will have some things left over. But how many things will I have left over? Well, the number of circles that would be left here is the number of terms. Right, and we can see this already starting to happen. If I have three terms, I'll draw a 3 by 3 and I'll have 3 left. If I have 5 terms, I'll draw a 5 by 5 and I'll have 5 left. So I'll have 5 more. Right? Cool. So this can be solved. This can be solved as number of terms times number of terms, which is this, plus number of terms. Which comes from here. Hope that made it more clear, but you can actually jump to the answer without that. Yeah, so we can say there's another 1 comes out for every term. Okay, so 2 is 1 plus 1. 4 is 1 plus 4 is 3 plus 1. 6 is 5 plus 1. And we'll get plus 1, plus 1, plus 1. And we'll get a whole sequence of number of terms of plus 1s, which will just be plus the number of terms times 1, which is just plus the number of terms. So this is 1 plus 3 plus 5 plus 7 dot 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 plus 151 plus 153 plus the number of terms, which we know from before is 77, once. Okay, let me rewrite that. 1 plus 7 plus dot 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 149 plus 151 plus 153 plus how many ones did I have? I had the number of terms of ones. We know the number of terms is 77. 77 ones is 77. We also know that this is 77 times 77 from before. So we simplify this to 77 times 77 plus another 77. Yeah. From before, we know, I hope I can remember, that this is this, 5,829. We have another 77. So this is equal to 5906. Answer. Okay, the last question, and again, it's a tough one. You have to think. You have to think for yourself. Is this? And that looks pretty hard. 2 plus 6, all the way up to plus 306. Again, we don't have our odd numbers that we like because we know how to solve, but can we relate this to something that we can solve? Pause the video and think. Okay, I've wrote on the board something that we know how to solve. How do these two relate? Well, we will notice that actually this, every single term is 2 times bigger than this. 1 times 2 is 2, 3 times 2 is 6, 149 times 2 is 298, 151 times 2 is 302, 153 times 2 is 306. Okay, so we can write this as 2 times this. And I'm going to write this in terms of our old one with 2 times each term. Okay, so I have 2 times 1 plus 2 times 3 plus dot 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 2 times 149 plus 2 times 151 plus 2 times 153. Yeah, and we can see that the common factor of all of these is 2. Okay, so I can rewrite this again as 2, 1 plus 3 plus dot 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 plus 149 plus 151 plus 153. And that shows why this is 2 times this, right? Because I showed it for each individual term. You don't have to do that, but it just shows you why that's true. That this is 2 times this, because each individual term is 2 times bigger. Okay, we'll delete this middle line. Okay, now that I have this, we 100% know how to solve this, don't we? We know this. It's 77 times 77. Okay, cool. So then we just have 2 times 77 times 77, which is 2 times our favorite 5829, which looks like 11,658. Hold that up. I just checked. It's not 5829, is it? It's 5929. 5929. So this is an 8. Okay, cool. If you have any questions further, send me a message back, send me an email. You can even write comments in this video. And yeah, let me know how you did.